I am going to now discuss another example related to displacement analysis of constraint mechanisms. This is the Nuremberg mechanism. You must have seen it in many places. So, we have here a slider which moves in this slot, and as it moves, this platform moves vertically up or down. This mechanism finds a number of applications. One application is shown on the right, this is called the Nuremberg scissor elevator. As you can see that this is a very compact mechanism which can expand and can reach to different heights, and this is adjustable. So, this example asks us to determine the functional relationship between h, which is the height of the platform, and s, which captures the displacement of the slider pin A. Essentially, the location of A is captured by s, and correspondingly h is the height of the platform. So, you have to determine a functional relationship between h and s. We consider a coordinate system. So, this is xy coordinate system. Now, from this triangle CGA, so this triangle, now CA you can easily read out, CA is equal to the vector CG plus vector GA. We use this variable theta, this angle, therefore, this S, this displacement S is equal to L cosine theta, where L is this length of this link. So, S equal to L cosine theta. From triangle CAE, this is this triangle CE, so this vector must be equal to the vector CA plus the vector AE. Now, CA, the vector CA is nothing but S I cap in the coordinate system we have chosen, and AE, this vector, can be represented in this form. Therefore, substituting these two here, we get the CE vector, but because S is already L cosine theta, which we have already seen, therefore, CE is nothing but, so this is L sin theta definitely, now we have two stages in this mechanism, this and this, both are L sin theta. Therefore, the total height is 2 L sin theta, and we have S equal to L cosine theta. We have two relations, H as 2 L sin theta and S as L cosine theta. If we eliminate theta between the two, which is done this way, H by 2 L is sin theta. So, sin square theta plus S over L is cosine theta. So, that square is equal to 1. Therefore, the relation between H and S is given by this equation, which is an equation of an ellipse. So, that solves our problem. There can be alternate actuation mechanism as shown here. Rather than applying force here, this is one possibility, you apply a force here and shift pin A. There are other possibilities, you can have prismatic actuators arranged like this. Here also from geometry you can determine the relation between the actuator throw and the height of the platform. Let us look at another example. This I will discuss, give an idea of how to solve the displacement analysis problem for more complicated mechanisms. Here I have considered this part of the mechanism, which is represented here. I have made these two hinges as the ground hinge of this mechanism. There are two ground hinges. S, this throw of this actuator, which is represented by this prismatic actuator, gives us the input, and the bin angle represented by theta is the output. Suppose I want to find out theta given S, which is the forward kinematic problem, or I can ask the reverse question, given theta what should be the throw of the actuator. Let us look at these problems. Let me put this coordinate system. If you look at this 3R1P chain, there are two chains as you can very easily recognize. There is a 3R1P chain and a 4R chain, which are coupled. If you look at this 3R1P chain, if you are given S, then you can find out this angle. Let me call this angle, which is a fixed angle, as alpha, and this angle, let us say I call it phi. This length let me call it A. Then given A, alpha and S, and of course, this length L 1, I will be able to find out the angle alpha plus phi using the cosine rule. S square is equal to L 1 square plus A square minus 2 L 1 A cosine of alpha plus phi. Now, in this equation I know S, L 1, A and alpha. What is unknown is phi. Therefore, we can solve this to find out phi. Once I know phi, then I identify the angle phi plus alpha as let us say theta 2, it is only phi, if this is phi, then we can look at this chain, this 4R chain. Look at this 4R chain, where phi is known, we have to find out theta, which is a problem which we have already solved. Therefore, using 2 steps you can find out theta given S. So, first we find out phi and from there we find out theta. If you ask the reverse problem, which means if we are given theta, then we just move in the reverse direction, we find out phi, which we have already discussed. Given the bin angle theta, we can find out phi from the 4R chain. Once I know phi, since alpha is known to me, so this total angle is known, this angle is alpha plus phi, and using the cosine rule I can find out S. So, given theta we can find out S just by the reverse procedure. So, this is just an overview, the detailed calculations can be very easily be performed. So, with that I will close this lecture.